Okay, content. Okay, the group meeting quiz. All right, we have 14 questions. Well, 12 if you don't count the first two.
All right, let's do it.
Let's get it on. Okay, so we need to use the normal probability pamphlet. Oh no, applet. I'm sorry, Apple. Okay,
Yeah.
when calculating anything, please remember to round to 3 decimal places unless otherwise specified, and do not round until your calculation is complete. Okay, it says find the margin of error for a 90% confidence interval when the standard deviation is 50 and the population is 25.
Okay.
We need a formula for that, right?
Yeah, so I was just looking it up. So I think you take, you know how you found the Z from 90%,
Mm-hmm.
which is 1.65,
Mm-hmm.
and then you multiply that by the standard deviation over the square root of 25, the sample.
Oh,
And
so it's
we have to solve for that. That should be the margin of error.
so it will be okay. Give me 1 second. Wait up. I have no idea. So it will be 161.645 times 25. No, times 50 divided the square root of 25. You said?
Well, wouldn't you do the 50 over the square root of 5 first?
Yeah, yeah, huh?
And then you multiply that by, so that's just 10, right? You
Yeah,
just
it's
take
10
that
because
times
if 50 is over
1,
divided by 5.
so
Mm-hmm.
it's 16.45.
Mm-hmm. Times 1.1645. Yeah.
It says to 3 decimal places. I don't know.
Maybe 16.
Is that what you did, Jordan? Did you get that?
I'm still trying to figure it out. I was just looking at it, so
Oh,
I just figured out what we were supposed to do
okay.
because I was confused for a little bit.
Wait. No, that's not the formula for the margin of error.
The margin of error is m equals, is it z times the theta over square root of n?
No, it's a margin of error is
Or not
equal
theta,
No, I
to
think so.
2 times the standard deviation over.
or over the population
Uh-huh.
square root. Okay, so is it just the 2?
Wait,
Mm-hmm.
what? Where are you getting 2 from?
If
It's
you go to
okay,
the
so it's
lesson,
it's in here for 95% confidence, with a 2 in front of it. But I think that's just how 95% is 2 standard deviations, so it's just the z-score.
Yeah, you have to find the z-score of 90%, which is the 1.645. And then you have to take that multiplied by 50 over the square root of 25.
Okay,
Okay?
1.645. That sounds right.
That's I mean, I just did the homework too, and so
Yeah, well, I
I'm
was
pretty
just
sure, I'm
doing,
pretty confident in that. That's how you do the margin, just because I did it a few times. But
yeah, I just was doing the prep assignment, so I was just trying to figure it out.
yeah, no, you're good.
Oh yeah, here is the margin of error is the C value times the standard deviation. I mean the standard deviation divided by the population, square root of the population times the C value. Or
Right.
whatever.
So since it says to round to 3 decimals, do you think we need to add a 0 or just leave it 0.45?
We should add a 0 because if we don't, it'll think we only put 2 decimals because it's the computer grading it.
Yeah. So, okay.
So is that what you got? What you also got, Jordan?
16.45.
Mm-hmm.
Yeah.
Okay.
Okay.
So which one is true?
Mm.
No, I want to say it might be the second one. But
Yeah, so I'm looking at it in the textbook and it says the mean and it has the mean and the mu in the same line.
Oh
And
yeah,
then S and
the point estimator on the little
yeah,
chart.
the little table thing.
Okay.
okay, so so x bar is a point estimator of mu,
Yeah.
Yes.
right? Okay.
Mm-hmm. Because the other ones are different.
Yeah, the other ones it's like both are squared or both are plane.
Well, what about the third one? Mu is a point estimator of x bar.
Well, I don't think so because the mean is a sample statistic and the mu is a population parameter.
Mm-hmm.
I don't know. Hold on.
So looking at let's say point estimator.
So okay, it says the statistics above are called point estimators because they are just one number, one point on a number line that is used to estimate a parameter. Parameters are generally unknown values. Think about the mean. If mu is unknown, how do we know how x is close to it? The short answer is that we will never know for sure if x is close to mu. This does not mean that we are helpless. The loss of probability and normal distribution provide a way for us. So,
Okay. Yeah, so we have to find the values of a parameter based on a statistic. So so the statistic is a point estimator for the parameter.
which is
So the parameter is the mu, right? Population
Yeah.
parameter.
Yeah.
Okay.
so is the second one right or wrong?
Second one's right.
Okay, it's a point estimator of u.
Anyway, can you say that again? So that's right because you said, why is it?
Because it says in the bottom that the laws of probability and normal distribution provide a way for us to create a range of plausible values for a parameter based on a statistic.
Oh, okay, got it.
The statistic is the point estimator for the parameter.
Okay.
Mm. I have like a little thing of stats notes that I keep with me. Come on.
Okay.
Okay.
Okay. Let's see. So 5. Figure out the point estimate is the 526
One second.
for number 5.
I think so. Yeah.
That's kind of what it was in some of the practice things. I'm pretty sure that's
5.6.
That sounds right, since
yeah.
the point estimator is the
Yeah.
bar.
Kind of makes more sense now.
Yeah.
Oh, so okay, so it's 5 to 6.
Yeah.
Yeah.
Okay. What is the margin of error for 95 confidence interval?
Okay. And equals.
I think that's a formula like 2 times. I mean,
Yeah.
you know which one I'm talking about, right?
Wait,
Yeah.
why do you keep saying 2 times? What is that?
I'm sorry, it's the standard deviation divided by the square root of the population
Oh, yeah.
times 2. Sorry,
Now, why do you do it times 2? Isn't it 1.96? Or are you just estimating?
It's times the z-score.
Which is 1.96.
It's 2 standard deviations. In a normal bell curve, or in any bell curve, 95% of it falls between 2 standard deviations.
I know, but did you guys do any of the assignments? They say the 95% is equivalent to 1.96. The 90% is equivalent to 1.645.
Because okay, so
I get what you guys are saying. They give you like certain Z's. Do you know how to shade it? Like if you shade the middle and you put 0.95 in.
I know what you're talking about, Becca.
Yeah.
But on the book it says something like if you go to like number 4,
Yeah.
it
So
says
if
put
you
it
go
all
to
together.
3.3.3, it shows that 95% is in 2 standard deviations, and so it shows that as you go down, it has it as 2 with the standard deviation over the square root of n.
Okay.
So that's why we're saying it that way.
Oh. Okay. I guess I just watched.
So I will use it.
Doing what I saw in the videos and stuff. So, well,
I know.
you can compare answer. I mean, I'm sure it's probably. I know it's close. So we'll just see whatever. Okay. Let's see.
So is that what we're using?
Yeah, okay, so as you go down, it says that the z-score for 95% is actually 1.96. And 2 is used to approximate it.
Oh.
So it says when you do compute everything, use 1.96.
Okay, so that formula that is on number 4 doesn't count then.
No.
Okay. Okay, no, I just wanted to, because I see the formula and I'm like, which is the formula? You know,
Yeah.
which one is the formula? Okay. So the formula will be is x minus, right? Minus
Are we
9.
just finding the margin of error?
Yeah, you just have to find the margin. So it's just like the first one that we did in number 3. So you just have to do 1.960 times 13 over the square root of 64.
It's 95 this time, right? 95%?
Yeah.
Yeah. So that's the 1.9. That's where you get the 1.96 from.
Okay. Let me actually do it because otherwise I'll forget. I'll forget it. So
Yeah.
so times let me see. 1 times 113 over 8.
Yeah.
Yeah.
Okay.
Bobby.
Times,
Let's tie.
times 1.96. I get 27.685.
That's what I got.
Wait, say that again?
I get 27.685.
Oh, maybe I did this math wrong. Oh, that's weird. I'm getting weird numbers. Okay, hold on. Ouch. 13. I get 3.185. For your margin, you got 27 something?
Yeah. I just did 113 divided by 8.
Isn't
and
it? Oh, it's 113. I wrote down 13. Sorry. That's fine. Okay. Okay, wait. So what did you guys? I'll just write down your number, I believe. What did you guys get?
27.685.
685. Okay.
Okay. How do you calculate number 7?
It's the confidence interval. It's the mean minus what we just computed, and then it's x minus, and then the second one for the number 8, the upper limit, is x plus m.
So you take 526 plus.
Well, the first one's minus because it's the lower limit.
Yeah, sorry.
Okay, can you say that again, please, Jordan?
So for the limit, it's brackets, so it'll be like 2 different points.
Oh, the brackets?
Yeah. So the first point is the mean minus the margin of error, which we just calculated before in the step before.
Oh.
And then the second bracket will be x plus the margin of error. So you find the lowest it can go and the highest it can go.
Oh. Okay, give me. My laptop is about to go loco. Okay. So x plus, minus, let me see, 27.685, right?
Yeah.
And then x plus 27.685.
Mm-hmm.
So, and then we subtract that from 526, right?
Yeah.
Yep.
For 498.35.
Yeah, so you got 498.315. Is that what you said? And then 553.685?
That's what I got.
In the upper. Okay.
Okay, so I got 498.315.
Yeah.
And the other is 553.685.
Yes.
And the lowest is, the answer is the second one?
No, the lowest is the first one.
The first one, yeah.
The one that's literally lower.
Oh yeah, I'm sorry. 498. 315.
Yeah.
Perfect. And the upper limit is the only one. The other one.
Yeah.
Okay. What would happen if the width of the confidence interval What would happen if the width of the confidence interval if Gina increases sample size?
Yeah.
I have the answer for that, I think.
I would say I don't know facts that was.
I have it decreases the width if you increase the sample.
Okay.
Oh yeah, as the level of confidence increases, the width of the confidence interval also increases. No,
Say
no,
that
wait. No,
What?
wait. No, it says, as the sample size increases, the width of the confidence interval decreases.
Okay.
Yeah, and then the next one, because I wrote the next one right above that, they'll both increase if you move it to a 99%.
Yeah, if the level of confidence goes up.
Yeah, then the
Yeah.
then the width will also go up,
Yeah, but if
increase.
so, number 9 is decreases.
Yeah, so number 9 is decrease, and
Okay.
number 10 is increase.
Okay.
Okay, 11. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. So which is the formula that we need to use for this?
What sample size do they need? Okay. So 50 is the margin. So we're using the margin of error equation. So we just want to find the sample size that they need for that margin of error of all those.
All right, so is n.
The one where you square it, right?
Yeah, yes,
Yeah.
yes.
No.
Yeah, I think.
Well, yeah, you'll need to square it, I guess, eventually.
So what's the confidence says 95. So we need the
1.96 for the z-score.
96
Yeah.
times
Times the
the standard deviation,
yeah.
which is 400.
And then divide that by the margin, and then square it.
The margin of error, which is 50.
Yeah.
Have you girls said clicked when it says click here if you love math?
Yeah.
I was like, I don't so. No, but I actually clicked it. It looks gnarly. I was like,
I know. I quickly went away out of that.
I get 245.8624.
And they always tell you to round up for sample sizes.
So it will be 246.
Yeah. 246.
Yeah.
Is that what you girls get?
Yep. I got.
Okay. The mean salary of actuaries is the mu is at 100 grand and the standard deviation is 36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis with a level of significance of 0.05. Oh my gosh. Okay.
It's like trying to remember everything that we've just learned.
Yeah.
Much.
Okay, but it says, what is the lower limit of this 95% confidence interval?
Oh, great.
So we have to use the formulas for this week, right?
Yeah, because we
Hmm.
gotta. So I'm trying to think what numbers we need. So we need like the sample size, right? We need 36.
Yeah. So we need this one, and this one, and this one.
We need to figure out the margin first, and then
Yeah. Well, we just basically all we need to figure out is the z-score
so
because
the
we have the standard deviation and we have the n. All we need is the z-score.
well, is that the
So
is it not the
for
1.96 in here, or is it something
oh, it
different?
is because it's 95%.
Wait.
Okay, wait. So, but what are we going to? What's is the 100,000 the one that we're going to be adding?
No, so at the bottom it says you collected a simple random sample of n
Oh,
equals 36 women's salaries and find that
yeah,
the mean is 111,000.
yeah.
Mhm.
Okay. So, okay.
So what do we use? So we use X?
Yeah, and then we use the standard deviation and the population, and then we use 1.96 because it's a 95% confidence interval.
Okay. 1.96. We use the formula, right? The
Yeah.
two parentheses or the ones that are
Yes. Yeah.
okay. If I can find it. Okay, so the C value times the standard deviation, which is 36,730 divided by the square root of 36, which is 6. Yes. Times. Okay. So what do you girls get? I get 11,998.4.
That's the margin of error. Now you want to subtract the margin of error from the mean.
From the mean, right?
Yeah.
Okay, the mean
so
is
did you get 99,001.53?
Yeah, except for now it wants us to round to the nearest whole number, so it would
Oh,
just be 99,002.
so what the mean is 100,000, right?
The mean
111.
is, yeah, 111,000.
Yeah.
So I get 99,002.
Yep. That's what we got. So the upper, I got 122,000. 998.
Yeah.
Give me 1 second.
I hate guys with freaking shotguns.
So 99,002 for the lowest,
Oh my.
Yeah.
and
Yeah.
then and the highest is 122,999
I'm sorry about that.
Say that again.
for the highest. I mean the upper would be 122,099.999.
You're in the corner, just turn around.
You're an
enemy.
I just
No.
did 998. Do we need to go up to 9?
No, because if you're rounding up to that nearest, you would just use the tenths
Yeah, that's what,
spot, so the 4 doesn't make it round up.
So it would be just
just 998, I think.
Okay.
120 or yeah, 122,998.
Okay, because like but yeah, because this doesn't need like it's not a person, it's not like a sample like the other ones, right? It doesn't need like a whole number.
Right.
Okay.
Yeah.
Do we only have 14, right? I think 14 is all of the above.
That's what I think too.
Let me see. Wait. Yes, it says sample is sample random sample. Okay. Population standard deviation is known. Population is normal distributed, or sample size is greater than 30. Yeah, it's all of the above.
How the hell is
Yep.
that? No fucking way.
We're good then? We don't need to go back over anything, right? I think we're good.
Nope.
I think we're good. I think I got it. Let me double check this.
Hopefully.
The number 3 was 16.450, 16.450, and then for 4 was the standard deviation. I mean, the mean, the standard, the sample.
mean.
You know the x, the x.
Yeah.
The point estimate of mu. And then it was
So
5.
I already submitted it, and we got 100%.
Oh,
Yeah.
but thanks for killing. Thank you, Jordan.
So what
You're
you're
welcome.
saying is, yeah,
Well, I'm checking everything, and then I'm like, we got it.
Yeah.
I guess that's one way to do it.
Yeah.
Yep. Well, you have 2 tries, so.
That's true.
No, but I
Good
usually
job,
like.
guys.
Good job, guys.
So I was, well, I keep thinking. Okay. Do you guys want to stay at 5 on Thursday? Do you have to work Thursday, Jordan?
I do, but I only work in the morning, so I'll be home at latest, I'll be home by 4 o'clock here.
Oh, okay. Do
So,
you want to keep it at 5? I was thinking we could go later, but
Oh my god.
mine is from 6 to 7 here. So I might be a little late. So maybe we should just keep it at 5.
It's fine at 6 my time, yeah.
Or, yeah.
so 8 my time is fine.
Yeah, we'll just do that. It should be.
Okay. Okay. Well, I mean,
I have to go to mine right after though, so hopefully it won't be too crazy.
Okay. Well, then I'll try to make sure I know what I'm doing so we can get through it quickly.
No, no. Me too. All right, awesome. Thanks, guys. I'll post this and yeah.
All right.
do all
All right,
that.
guys. All right, guys. See you on
Thursday.
Thursday. All right.
Yeah.
Have a good night.
You too. Good night.
You
Bye.
too.
Bye.
All right. Bye.